Hi, my name is Michał Karykowski. I work for Allegro as an Adobe data platform engineer. My team is responsible for building and maintaining big data ecosystem. I'll talk about expanding data and analysis ecosystem in public cloud. And basically, it will be more about our transition, but still incomplete. Okay, so a few words about things you will hear today from me. We will start with big data and analysis ecosystem at Allegro. I will describe it in a few words. Secondly, I will tell you why consider using public cloud. Why is it worth or not? Later, I will describe you why going cloud is difficult. And in the end, I will tell you how it look like at the moment, how our ecosystem look like at this moment. Okay, so our whole ecosystem is built around Hadoop. And here we got some information. We have one big cluster reaching the limits in some points. An example, number of files or our capacity scheduler is not enough for job specification. Our whole cluster have more than 217 physical servers. We store about 16.6 petabytes of data. Last year, we almost double our data stored on a cluster. We have almost 60 terabytes of memory and a lot of users. Also, over last year, we almost double our users from analysts through developers to managers, so everyone can use the data in a cluster. As a data processing engine, we used Spark. In our cluster, we support versions from 1.6.2 to the newest, almost the newest 3.0.1. Most popular is whole bunch of 2.4. It took about 75% of processed jobs. But unfortunately, the old, very old one, Spark version 1.6.2 is heavily used by a lot of processes. In case of ad hoc analysis, we use Jupyter Notebook with Spark usage. And if someone wants to use some SQL-like engine, there is an option to use Hive, Hue, or Alation. If we think about reports, analysts use Tableau. But now, if it is possible, we use Data Studio because we use in cloud Google provider. I also have to mention about Apache Airflow. We implemented Airflow relevantly recently, but now it's one of the most important tools in our toolset. We have two kinds of Airflow, analytical one and developers Airflow. The analytical instances are made into 24 instances, and we maintain them to analytical people. And we have more than 80 developer instances, and the teams maintain by themselves these instances. And we have many more other stuff and processes, but it's not so important now. Why consider using public cloud? It's everything you hear today is based on our experience, and so it will not be of course that it will work for everyone. So a lot of maintenance. Our cluster gives us a lot. We have on-premise data center cluster and we have to think about budgets and server orders to be always ready. for increasing usage of cluster. We do it mostly annually, but sometimes in case of some emergencies, we have to do it more often because it's not very easy to get servers in a moment. We have to think about actualizations, including systems, drivers, kernels, patches, tools and versions of packages, and many more. Being up to date is very important to have enough security in the system and to give people everything what they want. Yeah, we have to face with damaging hardware, especially disks. Try to imagine that the cluster has about 3,200 disks. And if they break, there is a job to do. We have to stop the node, remove disks with remote hands, start node, and after repair or replace, we have to do it the same again and rebalance data on the node. It takes time, and it is, of course, unwanted kind of work that we have to do. Okay, so we have also some difficulties with custom way of doing some data processing or trying to approach to prepare jobs and pipelines by teams. Teams always want to do their job do best. So we have to help them as long as we can, and if it is possible. Also, if there is something very interesting, we should learn about and try to implement it to the ecosystem. Teams sometimes want to have new tools and new libraries, for example, in the space of Spark or Airflow. And if we try to implement new things in the ecosystem, it's connected with more maintenance for us. Yeah, reaching the limits of our ecosystem, as I mentioned earlier, it's not only that we have to face that the number of small files in a cluster, memories on hosts, reaching the limits, disk I/O, scheduler scalability, and upgrading versions due to some support, etc. Okay, but cloud give you almost ready ecosystem. Whatever you choose, it gives you a variety of tools, ready components. You can choose tools what fits your needs and what fits your daily work. But you should choose the proper provider. FastSQL, we had Presto, and people in our company liked it a lot. Unfortunately, maintenance and some limitations forced us to give it up about 2 or 3 years ago, and we decided to resign with Presto. But cloud give you some tool which give you FastSQL engine. And month by month, cloud providers give a lot of updates, features, and new tools. Not only we try to do our job in the best way, they also. And last but not least, we can do something new. We can learn new things. In some cases, we can do courses on and even some certificates. That motivates a lot for a lot of people. So why going cloud is difficult? It should be easy. Yeah, but not sure. So I will show you something about our transition and the challenges we faced. So specifying your needs. We have to check all cloud providers and select what fits you most. It's not always obvious. We decided to work on a Google toolset. It took us a lot of time to make that decision, but for now we are pretty happy about that decision. Connecting your work with working ecosystem with a cloud, it's not very easy. People have some kind of habits. We try not to change their whole world which they like. Let's try to implement some small changes, extend your tools, and cover some cloud options under the well-known admin tool for people admin. Its first touch. It's if it's going in the right way, show or give people more than they expect even. Convincing people in our company is not very easy. Management will be convinced if the money is okay, but it's not enough. You have to focus very much on convincing our data users. We have to explain them why is it worth, why they should move their working workloads and pipelines to another ecosystem. Mental barriers and habits in case of money, it's also very important because with on-premise data processing, it is almost free. Cloud show you your costs, how much money you spend. We strongly realized about it using FastSQL BigQuery engine, which show a cost of simple queries on a real data. At the beginning of the process, people were sometimes scared to run BigQuery queries because they saw how costly it is. And thinking from the beginning about cost optimization, it's not very easy. It's also connected with money because it's not virtual algorithms, but real money paid to provider. So try to imagine that you have to do everything from the beginning very clearly and in a cheapest available way. How to have all data in the cloud? In this case, we have to realize that the current data is changing second by second. And secondly, copying data use a lot of resources on our cluster. So we copy a lot of data, especially after midnight, and it led us to maximum network bandwidth. In other time, it make some delays in a data processing based on our cluster. So everything should be optimized. Yeah, it's the different approach to deploy jobs and pipelines and other stuff. Even if we think that moving pipelines should be easy because of some similarities with used tools, it's not so easy. You have to face many little problems in many points, and sometimes the problems are going bigger. Improving existing work. If you do something new, do it better. So implement things you always wanted to have. And people say sky is the limit or unlimited scaling in a cloud. Definitely not unlimited. Somewhere there is always bare metal. At the beginning of our journey to the cloud, we when we were sure that we are going to GCP, even Google asked us about how we predict the scale of our usage of some tools to be 100% ready to scale up in case of some scaling. And not everything could be implemented from start. In our case, at the beginning, Google couldn't guarantee us that our data will not left European Economic Area. And that was a part of our responsibility to keep data safe of banking data. That led to separate some data processes in our copying tool, making some blacklisting, etc. Of course, it led to some changes in Google processes. So later we could copy even that special kind of data. But it took some time. Need to make some trainings for people in the company. From the beginning of copying data processes, we had to learn people at our company, especially analysts and developers, how to use GCP in our way, how we made some processes, which tools are for what kind of job, even not to be afraid to spend money if it is really needed. And types everywhere. It's not so easy to simply copy data from one kind of data source to another. There is plenty of spaces to make something wrong. Avro, Parquet, Hive types, BigQuery types, there is always something to do with conversion of types to cast or parse data. Even Spark in one upgrade has a big change with Spark Avro library, and that led to about a year of planning how to replace currently used data in some important tables. So there is a lot of small things that make a big problems. Accidents, even Google has some accidents. We had one when Google deployed some change in BigQuery, and that led to some downtime for analysts because of some incompatibility of types after the deployment. After they realized that it was a big change for some companies, they had to make rollback and test that change with big clients, including us. A lot of tools are in beta versions, and others are constantly changing. What is more, some of the changes are made at our request. It's good because they are changing to be better for clients, for users, but from time to time it costs some maintenance. It's not very needed thing for maintenance team. Okay, so how to manage infrastructure? At our data center, we use Puppet. We had an opportunity to start in a similar way using virtual machines in the cloud, but we decided to use ready tools and go with Terraform. In this moment, we are in a phase that we try to fully automate this process. We decide to use standalone version of Terraform, plenty versions of Terraform, probably in the future. And this way, it led us to have GCP infra as a code, but very close to the teams. And what is the next challenge? Which things should be allowed to people or teams? How to manage user privileges? It's not an easy way. Some people think that if we have a graphical interface, we should be able to do everything what is available. But it is a production ecosystem. Deploys should be auditable and reviewable. In this moment, people have a lot of rights, but we think how to process some changes to make the ecosystem very secure. And managing budgets. if something is related to money, it's not a trivial. Convincing some management people is also not obvious. So spending money should be argued with examples. Okay, so how does it look like at the moment? Let's think, how many data we copy day by day? On last Monday, as I checked, it was almost about 40 terabytes. Yesterday, it was about 37 terabytes. This month, close to 1 petabyte. We copy close to 1 petabyte of data. Per day, average per day is about 37 terabytes, but not always. It's not always an incremental growth. There is a bunch of data that is overwritten for some reasons. Okay, so how many data is on BigQuery? More than 10 petabytes. It's closer to 11 petabytes. But we still do not copy whole data sets stored on Hadoop. We think how to face with this kind of problem, because also it's not a trivial problem. We have a lot of data sets, a lot of users, and data processes should be clear for everyone. Okay, and how many BigQuery queries we've got? As you see on the chart, it's linear growth. In this quarter, I think we will break 400,000 queries by whole company. And how to manage, how we change our network connection with Google. At the beginning, we had copying data processes started, and we reached the limits of our network bandwidth. It was about 10 gigabits per second. And reaching the limits, we had to optimize the process because there were no space to improve in a software these days. Later, the network team expanded the bandwidth 4 times, up to 40 gigabits per second. And in this moment, in late hours at night, we reach almost 20 gigabits per second, but whole day average is about 4 gigabits per second. So we are pretty secure for this moment. Okay, so teams involved in building ecosystem. In one hand, we had infrastructure teams and developer teams. We work together very hard with building new ecosystem and being pretty sure that everything is very easy for our clients. In other hand, we had adopters also selected into groups, analysts and developers. Both kind of users have different needs and different approach to work with whole environment. And despite of moving some processes to cloud, our Hadoop cluster is still growing. You saw the scale because I mentioned before. And we have a lot of meetings with people from Google to improve some tools and to be up to date and to plan a near and farther future with our ecosystem. If it is possible, we strongly encourage people in a company with use of BigQuery and other GCP tools to make migration faster and easier for people. Okay, And that's all for now. But if you want more, I strongly encourage to join our team as a big data engineer or software engineer in big data team. This way you can feel all these challenges from within by participating in them. Thank you, and I hope we will see in questions section.